flying animals, what do you think of? Birds, butterflies, or bees might first come to mind. But what about spiders? Even though they don't have wings, it turns out that spiders are actually some of nature's best aviators. So, how do spiders take to the skies? Lightning storms are one of nature's most powerful displays of Earth's electricity. But even under normal weather conditions, electricity is all around us. The atmosphere holds a positive electric charge, while Earth's surface holds a negative charge. Just like with magnets, similar charges repel away from each other, and opposite charges attract. This interaction creates something called an electric field. The force of this electric field is what allows for some spiders to defy gravity in a remarkable behavior called ballooning. It typically begins at high, pointy areas where the Earth's electric field is the strongest. First, a spider drops an anchor silk to secure itself. Then, it raises its two front legs in the air and uses special fine hairs to sense wind and electrical conditions, sort of like a built-in weather station. If the conditions are right, the spider then tiptoes on its back legs, raises its abdomen, and releases its silk to the air. The silk strands are charged, which causes them to repel away from each other rather than tangling. This form of static electricity is just like what happens to your hair after rubbing it with a balloon. Now, ready to set sail, the spider breaks off its anchor line and lifts into the air using the force it gains from the electric field and wind. Once airborne, spiders likely use their legs to balance or control speed during their dangerous journey. Most of these trips are short, but some can last for thousands of miles.
Sometimes scientists assume that, like kites, ballooning spiders can fly because their silken threads generate enough lift to ride currents of air. But according to a study published in Current Biology this week by researchers at the University of Bristol in the UK, they don't actually need a breeze at all. It turns out spiders can fly using the electricity in our atmosphere.
The mystery of how spiders can fly for thousands of miles even in the complete absence of wind has finally been solved. Sometimes, when it rains or when they feel the urge to migrate, spiders get out their little silk knapsacks and balloon away. This ballooning behavior is well understood by spider scientists, but researchers have recently discovered that electric fields can not only trigger the behavior, but also provide lift. The latest research shows arachnids can make use of electrostatic charges in the atmosphere to power their journeys. This force, known as the E-field, can be detected by many insects and is used by honeybees to communicate with a hive. They travel via the atmospheric potential gradient, an electric circuit between Earth and the ionosphere, the part of Earth's upper atmosphere that's ionized by solar radiation. Sensory hairs called trichobothria found on the surface of the spider's exoskeletons move in response to electric fields. This suggested spiders can feel the charge in the air using the same sensory hairs used to detect a breeze. Many spiders balloon using multiple strands of silk that splay out in a fan-like shape, which suggests that there must be a repelling electrostatic force involved.
For a long time, scientists assumed that, like kites, ballooning spiders can fly because their silken threads generate enough lift to ride currents of air. But according to a study published in Current Biology this week by researchers at the University of Bristol in the UK, they don't actually need a breathe at all. It turns out spiders can fly using the electricity in our atmosphere.